Good morning, everybody. It is time to now take everything that we've been using with right triangles, meaning Pythagorean Theorem and the right triangle trig, and put it into action. We're going to be solving word problems using everything that you've learned. So let's take a look at the first problem. And it says that a painter has a 25-foot ladder to paint the high points of a house, and that the ladder makes a 38-degree angle with the ground. So the first thing we need to do is we need to sketch a little diagram. So we're going to have our little house over here. Here's the ground, okay? And he's got this ladder that is 25 feet long. I would not necessarily want to be on that ladder. Okay, so it's 25 feet long. And it makes a 38-degree angle with the ground. So ladder, ground, 38 degrees is right here. So we're asked two questions. One question is, how far up the house does the ladder reach? So we're looking for this height right here. This is the height up the house. So let's just call that y for height. So we have to think about this. We have this angle right here as our theta. This is the opposite side, and this is the hypotenuse, which means we should be using sine. So let's set this up. The sine of our angle equals the opposite length, which we don't know, divided by the hypotenuse length, which we do know, it's 25 feet. We know in order to solve this, we're basically going to cross multiply or multiply each side by 25. So we get 25 times the sine of 38 equals y. And I think it's important that you put that in your calculator and make sure that you get 17.2 degrees. If you don't, make sure you're in degrees. Definitely check that. I always put the 25 before the trig function, just because I don't want it to say like the sine of 38 times 25. So I always put the 25 or whatever the number is in front. So that's just something to think about. Okay, so second question, same diagram, is how far from the house is the base of the ladder? So now we're looking at this. What is this distance? I'm going to call that x. So now we have, here's our theta, adjacent and hypotenuse. I would always go back to use the given value, by the way, because if you made a mistake on the height of the house and then you use that mistake in the next problem, now you're getting two wrong. So adjacent hypotenuse, we know that that's going to be cosine. So the cosine of 38 equals x over 25. Again, we're going to just multiply by that 25 on each side. That goes straight in our calculator as you see it, and you should get 19.7 degrees, or 19.7 feet, 19.7 feet. Okay, so it's a pretty straightforward use of what we've learned about SOHCAHTOA. So let's keep going. This has a little direction in it, not too much of a big deal, but it says that a boat leaves port and travels 25 miles due north. Okay, so it's going north. Oops, didn't grab my pen yet. Going due north. And then from there, the boat turns and travels due east. So our diagram is going to look something like this. I always like to think about what it's going to look like so that I know where to start the diagram. So from here, I'm saying this is the port, due north for 25 miles. The boat turns to the east and goes 40 miles. So here's the boat right here. Okay, so let's complete our triangle. Give ourselves the right angle that we know is there. And the first question is, how far from the port is the boat? Well, think about this. Does this have anything to do with the angles in this problem other than the fact that we have a right angle? It does not. Okay, so we have two sides of a triangle. We are looking for the third. We're going to use the good old Pythagorean theorem. And by now, you can probably adjust it and not necessarily needing to start with a squared plus b squared equals c squared. You might be able to jump right to this step. Okay, so all I did was really move the square root over. But when you put those values in your calculator, 25 squared plus 40 squared, you should get about 2,225. And this is a problem where we would just round to the 10th. So you can drop it right in your calculator, and you should get 47.2 miles, okay, approximately. This is not a problem where we would want an exact radical for an answer. Okay, second question for the same diagram is, what are the measures of the two acute angles? So to be honest, it doesn't really matter which one we start with. What I know is that those two angles are complementary. So I'm just going to start here. And obviously we have opposite and adjacent. Again, I would not use the hypotenuse in case I made a mistake there. That's just my thing. So tangent of theta equals opposite over adjacent. And we all know to solve for this angle, we have to take the inverse tan of each side. And to be honest, by now, you might already be jumping to this step that I'm writing right now. And that's totally fine. Put that in your calculator, inverse tan of 40 over 25, and you should find that the angle is a 58-degree angle. Okay, so if this angle is 58 and these two angles are complementary, to find the other angle, we can simply do 90 minus 58. And we get 32 degrees. So this is a 32-degree angle. Theta was a 58-degree angle. Okay, let's turn the page for another example. I forgot I have to explain to you angle of elevation and angle of depression. You'll probably remember this a little bit from geometry, although it was a while ago. So basically, angle of elevation is, think elevate up. So if this is the horizontal, it's up from that. And depression means down, right? So if this is the horizontal, it's down from that. What's really important, and it's going to be helpful to us, is that if this is horizontal, this is an angle of depression. Okay, so an angle of depression. This is also the horizontal. This is the angle of elevation. What's really important to know is that the angle of depression is equal to the angle of elevation. I don't know if you remember, if two parallel lines are cut by a transversal, alternate interior angles are congruent. That's why that's true. So those two angles will be congruent. And that's going to be helpful because sometimes when we're doing a problem, our angle of depression might be outside of the triangle that we need. So we can actually put it inside the triangle using that little rule. So it will be helpful. Okay, so let's check this one out. It says that Kelly looks out her second-story window and she sees Miranda across the street. Kelly is 18 feet above the street and she looks at an angle of depression of 32 degrees to see Miranda. So let's sketch our diagram. Okay, so up here in her second-story window, right here, happy to see her friend, is Kelly. And down here on the street, okay, looking up to see her friend is Miranda. It says that Kelly is 18 feet above the street and that she's looking to see Miranda at an angle of depression of 32 degrees. This is super important. Pay attention. This is the part that people often struggle with. What you have to envision is that this is the horizontal. So this out here is the angle of depression. So this angle is 32 degrees. Okay, of course, we're assuming this is a right angle. Now, what's important is if she's looking down 32 degrees to see Miranda, Miranda is looking up 32 degrees to see Kelly. Miranda has to look down 32 degrees. Kelly has to look up 32 degrees. And again, I could do this horizontal here. Okay, we're pretending that she doesn't really have height because that would add a little a little extra to this problem. Okay, so how far is Miranda from Kelly? Now let's look at this because this is another thing people get wrong. Here's Miranda right here. Here's Kelly right here. We want to know this distance, which is the hypotenuse of the right triangle. So this is our theta, 32. We have opposite and we have hypotenuse that we're looking for. So we'll use sine. So sine of 32 equals 18 over the hypotenuse. You may be able to skip this step right here, but I'm going to write it out. We kind of cross multiply and then divide by the sine of 32 on each side. Okay, so you're going to drop that in your calculators and make sure that you get approximately 34 feet. All right. The last one I'm going to do with you is a problem where we kind of have to think about Pythagorean or SOHCAHTOA twice. So it says you're looking at the Eiffel Tower from your hotel window. You have to look up to see the top of the tower and down to see the bottom of the tower. You are about 200 feet from the tower. You're trying to figure out how tall this tower is. So what I want you to do is I want you to pause this video and try to draw a diagram of the tower and label it. And let's see if you and I agree. Okay, I drew a portion of it. So here you are, right here, and you're about 200 feet from the tower. Now you have to look up at an angle of 72 degrees to see the top of the tower. So that means you're looking up here, 72.2 degrees. And it also says in order for you to see the bottom of the tower from the same location, you have to look down 65.6 degrees. So what you're going to have to do is you're going to have to find the height from here to here. We know this is a right angle, so we'll call that x. And then you have to find the height from here to here, okay, from where your height is to the bottom. Okay, I'm going to call that y. And then you're going to have to add those two values, and that will tell you approximately how tall the Eiffel Tower is. So let's see if you know what to do. You're going to pause this video. And let's see if you can write the trig ratios. Once you write the trig ratios, turn it back on. Let's make sure you have the right things written down. Okay, how'd you do? The one I have in purple is for this height. The one I have in pink is for this height. Once you have those values set up, make sure you understand them, go ahead and solve. And what I can tell you is you should get a height of approximately 1,063.8 feet. Okay, so pause the video, go ahead and do it, and let's see if you get the right answer. Okay, so take a look at my calculations, make sure you were on track with everything, and this should lay a good foundation for you to be able to do some word problems on your own. Have a wonderful day, everybody.